3D virtual worlds is as easy as playing a video game.
Those two little red balls represent his hands. They're actually floating between his thumb and forefinger. And when he grabs with his middle finger, he can actually grab the fabric of space, and that's how he's moving through the scene.
If someone launches a missile at the United States, depending on where it was launched, we could have less than 5 minutes to track it down and destroy it. The technology inside this Boeing 767 can do just that.
Target in view. Interceptor has been launched.
For mountain bikers, the all-terrain missiles.
We have a hit.
This program is brought to you in part by Singapore Airlines, offering...
The hardest thing about detecting an incoming missile is, number one,
knowing that a missile's coming in the first place.
and number two,
Determining the exact course of that missile so that hopefully you can intercept it.
exactly right. At this point, enter the Airborne Surveillance Testbed. Missiles can take between 5 and 30 minutes from launch to impact, depending on the type of missile and the distance it travels. That means that if a missile were launched at the United States, we could have as few as 5 minutes to learn it had been launched, to track its course, and to get one of our interceptors up to destroy it. The more information we have about an incoming missile, and the faster we can process it, the better our chance for survival. The Airborne Surveillance Testbed is designed for precisely those reasons. Behind me is a typical Boeing 767. Well, except for the big goofy bump on the top. Inside that cupola is an infrared sensor, a system so sensitive it can detect and track a missile from over 1,000 miles away. This project is the brainchild of the U.S. military, of Boeing, who has adapted the 767, and of Hughes Aircraft, who designed and built the infrared sensor or telescope. Combined, the three organizations have redefined the state-of-the-art in missile defense. You got to be asked every time somebody sees this, what is under the bump on the plane? In a nutshell, what's in there?
A giant infrared telescope, about the size of 2/3 of, say, a Volkswagen, about 5,000 pounds. That looks out through that window when we're up at altitude.
Boeing invited us aboard for a test flight where they simulate a missile tracking scenario.
Runway 13 right, clear for takeoff.
Once at altitude, about 45,000 feet, the door of the cupola, which houses the sensor, is open. At that point, it begins to scan thousands of square miles with an eye out for missiles.
Target in view.
The infrared sensor looks for the heat of a missile against the cold background of space.
Interceptor has been launched.
And when it finds that, the action begins. It's not enough for the plane to recognize, hey, there's a missile out there. It also has to determine what type of missile, its path or trajectory, and also what's the point and time of impact, or better yet, interception.
Copy that. Successful intercept.
It's got 38,000 detector elements, individual detector elements in there. Well, each one of those detector elements is delivering data 10,000 times a second. If you don't handle those 38,000 pieces of data almost instantaneously, 1/10,000th of a second later, you got another 38,000 pieces of data waiting to be handled.
Once all that information is processed, it's displayed on monitors inside the plane and interpreted by a specialist.
After 100 or so of these missions, you learn from looking at this, what represents a true target, a potentially hostile target versus false alarm.
With as few as 5 minutes separating safety from destruction, it's easy to see what an asset this volume of data can be. But, of course, no one's planning to send a 767 into battle. This whole project remains a test bed, and if adopted by the military, would be substantially modified to meet combat specs. Assuming this technology ends up working its way into the battlefield, what's an improvement this can bring? What can this do better, hopefully, than any existing system?
Well, if you can take a system such as this and reduce it and make it economical and deployable, then you can put a sensor up high enough so you can see over the horizon. And therefore, you can get early data. It gives you more reaction time. Possibly gives you more than one chance to intercept a target. So if you miss the first time, you can try again.
Before this project was declassified, the folks at Boeing in Seattle had a great answer whenever anybody asked about the 767 with that big tall bump on the top. They told people it was the official private plane of the Supersonics basketball team. They really did.
Time now for our step back question.